Yes. Today we discuss about the topic of characterization of nanoparticles. About the introduction, nanotechnology involves the research and technology development at the atomic and molecular level in the length of scale of approximately 1 to 100 nanometer in the range. So biotechnology is the use of biological process to convert this molecule into nano levels. So the interface of these two words, nanobiotechnologies, which comes the combination of nanotechnology and biotechnologies. So first, the nanotechnology origin introduced by the concept of there is a plenty of room at the bottom. So that scientist Richard Feynman, a Nobel laureate in the physics in 1959, which he described the possibilities of synthesis via direct manipulations of atoms. The term nanotechnology was coined by the professor Nori Tanikuch. So about the nanomaterials, these are the commonly we have to define the materials are in the ranges of particular scale we are called nanomaterials. So these are the common example for the nanomaterials. Then we have to classify that nanomaterials at the length of the scales. There are 0D nanomaterials, 1D, 2D and 3D dimension of the nanomaterials. So 0 dimension is the all the 3 dimensions in the nanoscale level we are called as nanoparticles. 1 dimension is the nanoscale and others 2 in the macro scale level. So examples are nanofibers, nanowires. In 2-dimensional nanomaterials are in the nanoscale, the others in the macro scales. Nanosheets and thin films are example for 2D dimension. 3D dimension, no dimension at the nanoscale, all are in the macro scale. The examples are nanostructure with the nanomaterial. These diagrams are show the different materials in the different wavelengths. So next we comes under the nanoparticle. What is nanoparticles? The particles are the size between in the ranges of 1 nanometer to 100 nanometer in the ranges. So all at the nanoscale, the physical, chemical and biological properties of the material differ in the fundamentals and valuable ways from the properties of the individual atoms and molecules. So these are the different types of nanoparticles: organic nanoparticles, hybrid nanoparticles, inorganic nanoparticles. So organic nanoparticles are example dendrimers and liposomes. Hybrid nanoparticles examples are hydrogels. Inorganic nanoparticle examples are carbon nanotubes, gold shell, iron oxide and then quantum dots. So now we are comes under the topic of characterization of the particular nanoparticles. How the material is converted into the ranges of nanoparticle. We are using the different spectral characterization techniques. These are the main basic techniques we are used to characterize the particular nanoparticle. Examples are UV visible spectrophotometer, FTR, XRD, AFM, TLS, EDAX and SEMS. These are the basic method. Many techniques also available for characterizing the nanoparticle. So these are the main techniques we are used for characterization of the particular nanoparticles. So these are the UV visible spectrophotometer analysis of the silver nanoparticle. In the UV visible spectrophotometer, we have to observe the particular peak, what the ranges will becomes. So based on the observance, we have to decide our particles comes under these ranges. Then second examples are FTR spectra. So FTR is mainly used for analyze the functional group and fingerprint region of the particular materials. So FTR mainly used for functional group analysis in the particular nanoparticles. Then we are using XRD. XRD mainly used for the average particle size analysis. So based on the using specific laws 2D sin theta, we are used for analyzing the particle size of the particular nanomaterials. Then we are used AFM, atomic force microscope, for the topography of the particular nanoparticles. So here we are seeing the topography of the particular materials, what the range surface will becomes. Then we are using DLS, dynamic light scattering, for the observance of the particular size which comes under the particular ranges. We are used the DLS for the particular size measurements. So mainly EDAX we are used for the particular metal signals. For example, I am using silver nanoparticles now. So what the silver signal will be appear or not. So the main element components in the silver metal that shows the strong signal peaks in the spectrum. Then we are using scanning electron microscope for the nanoparticle analysis. In scanning electron microscope, we are used for 3D shape of the particular nanomaterials. So here we are seeing the different magnifications of the particular nanomaterials. So TEM we are mainly used for the analyzing of the 2D shape of the particular nanomaterials. Thank you, students.